When dealing with inclined member, the applied loads need to be resolved into components along the local axis of the member. Only then, we may proceed with determining the internal forces developed in member. The transverse component is our basis to determine shear force and bending moment. The longitudinal component helps us to determine the axial force. For inclined member, these axes are deviating at an angle from their counterparts in global coordination system. There are three types of loading that we may encounter. The first kind of loading is the simplest case, where the load is already acting along transverse direction. In this case, there is no need to process the loading, and we may proceed with determining the internal forces. Note that this kind of loading does not induce axial force in member. Wind and water pressure usually exert this kind of load on member. For the second kind of loading, the direction of load is parallel to the global y-axis. This type of loading needs to be resolved into local x and y components. By knowing the angle between global and local axis, the transverse component will be W cos theta, while the longitudinal component will be W sin theta. This kind of loading is usually exerted by self-weight or superimposed dead load on structure. Let's say we have a 5-meter member inclined at 30 degrees. 5 kN per meter of loading is resolved into 4.33 and 2.5 kN per meter along local x and y axis respectively. For the third kind of loading, we will be looking into loading that acts along the projected length of member. Let's say we have a vertical load of W distributed along the horizontal projection of member, which turns out to be L cos theta in length. First, we need to distribute this loading on member, noting that total load exerted should be the same even after conversion. Therefore, the distributed load U should equal to W cos theta. What we have now is the second kind of loading. To obtain the transverse and longitudinal components of this loading, we transform the load again like what we discussed previously. This kind of loading usually comes from rain and snow. Let's look at our 5 kN per meter distributed load. The transverse and longitudinal components of applied load are 3.75 and 2.17 kN per meter respectively. We have now discussed about 3 common load patterns that may act on an inclined member. Have you seen other patterns before? Tell us how you solve it in the comment section. Thank you for watching. If you find this video helpful, please share it with your friends. We will see you guys soon. Goodbye.